Hello, this is a video that goes through how to evaluate math problems in Java. So a few rules to start you out. The first rule is you're always going to evaluate math problems using the rules of PEMDAS. You'll note that there's an extra M in here, and that's because in Java there are 5 different mathematic operations instead of just the 4 main ones that you're used to in math class. The second big rule is that you're going to evaluate what is to the right of the equal sign and use that information to solve your problem. Whatever data type that you might see on the left-hand side of an equal sign, if you're assigning it to a variable, is just how you're going to store the answer. It actually does not have an impact on how to evaluate the problem. And when you're going through and you're solving a problem, the resulting data type is determined by the largest and most specific data type in that individual problem. And we'll talk about that in a few slides, a little bit more in detail. And when you're dividing an int by an int, the result is actually going to truncate, which is the same as saying that it's going to drop the value after the decimal. You do not round the value. So if I were to divide something and end up with like a 0.4 normally, that 0.4 gets dropped. It will not get rounded down. If it would be 0.999 after the decimal, that gets dropped and you would ignore it and you would just get the whole number value back. So taking a look at PEMDAS, which hopefully you are familiar with from math class, the first thing that you always evaluate is anything that shows up in parentheses. Next, you're going to do exponents, but there's no symbol in Java for exponents. You're going to use one of the math methods. So if I want to do 3 squared, instead of doing 3 squared or 3 with a symbol and then a 2, you would say math.pow 3, 2. And math is a class that's been pre-written by somebody else. It's one of the basic classes in Java. And it has many methods. It has sine, cosine, tangent, all of those are methods that will evaluate all of those things for you. We're only going to look at a few of the methods in the math class, and you'll explore them in an assignment shortly. So once you've evaluated anything in parentheses, you are going to evaluate any multiplication, modulus, or division problems, and they all have the same precedence. So you don't always do multiplication before division or division after modulus. Whichever of those appears first, left to right, is what you're going to evaluate first. And the same principle applies to addition and subtraction. You always evaluate from left to right. So it's not always addition first, subtraction second. It's going to be whichever one appears to the first, or evaluating from left to right through a problem. So to take a look at a few just basic problems, some of the easiest ones, if you had 12 plus 4, obviously your answer there is just going to be 16. If you had 12 minus 4, your answer there is going to be 8. 12 times 4, your answer there is going to be 48. 12 divided by 4, your answer there is going to be easy. It's 3 because 4 goes in 3 whole times. It gets a little bit trickier when you go and you look at values where the division would actually normally result in a decimal. So if you normally divide 12 by 5, it goes in twice. You subtract 10, you would have 2 left over. You would put in a decimal point, 5 goes into 20 4 times, so you would say 2.4 normally would be your answer here. You would subtract 2, and you get 0 left. But remember what I said, if you have an int and an int, you only have 2 whole numbers, your answer is going to result only in a whole number. This is where that truncation happens. You're just going to drop that decimal point. As soon as you introduce a decimal point, whether it be on the left side or the right side or both sides, as soon as there's a decimal point, then you get a decimal answer. So you want to be very careful and look at the data types that are being used in a problem when you're evaluating. And then you have modulus, which sometimes is called just mod, but other times you're going to hear it as modulus. And what we're looking for here is the remainder. So when I divide, and you'll notice that divide, here's my division sign, and the division sign shows up kind of inside here, but it's got the two extra symbols, percent sign. So that's telling me it's the remainder. So if I took 12 and I divided by 4, it goes in 3 times with a remainder of 0. I don't have anything left over, so my answer here is just going to be 0. If I take 12, though, and I divided it by 5, 5 goes in twice, subtract 10, I have a remainder of 2, and that's going to be my answer here. And then 2 mod 5, and this is where people have questions or problems very often. Think of it this way. If you have $2, you're trying to buy something that costs $5, can you buy that thing? And the answer to that is no. Well, how much money do you have left over? You still only have $2. So if you were looking at it, you're trying to divide 5 into 2. Does it go in? No, it does not. You subtract 0, you still have a remainder of 2 things left over. So anytime that this number on the left is smaller than the number on the right, that just automatically becomes your answer, because you're going to have all of those left over. Taking a look at determining the data type, it's very easy. You usually don't even have to do any math to determine the data type. You've got whole number, whole number, whole number. So the data type here is going to be an int. As soon as one of these numbers becomes a decimal, so this becomes 5.0, or if it was 12 plus 4.0 divided by 5, or 12.0 plus 4 divided by 5, or any combination there, then it becomes a double. And even if you don't know what the value is, so x has some value, z has some value, you don't know what they are, you're looking at, okay, here's a double, my answer is going to be a double. Here's an int, another int, another int. There's no doubles. My solution has to be an int. And here I have an int, and a double. My solution has to be a double. If I tried to store this into an int, you would get back an error, because it wouldn't know how to take this decimal and make it a whole number. So if you do something like int a equals 12.0 divided by 5, you're going to get an error, because it's not going to like trying to put this decimal into an int. So you want to be careful as you're going through that. So taking a look at kind of solving some problems that actually have, a few steps, following my rules of PEMDAS, I'm going to look first and evaluate anything that is inside of parentheses. And inside of those parentheses, you're going to look to evaluate what shows up and follow those same rules. So I'm going to look first for any multiplication, modulus, or division. So the first thing that I evaluate here is actually the 3 times 2. So I end up 7 plus 6 minus 6 mod 4 divided by 2. I'm still going to be inside my parentheses. I've got addition, subtraction, but I have a modulus. So I divide 6 by 4 and I get 2 things left over. So now I have 7 plus 6 minus 2 divided by 2. So now addition and subtraction, I evaluate the one on the left first. So I get 13 minus 2 divided by 2. 13 minus 2 is going to give me 11. 11 divided by 2. Notice that they're both whole numbers. So when I do my division, 2 goes in 5 times. I have 10. I have a remainder of 1. I don't care about the remainder because both of these were whole numbers. So my answer here is going to be 5. And that will be my final answer as I'm going through this math problem. Going through this one, I've got another one, no parentheses, so I don't have to worry about that. I do my mod. Well, this is going to be real easy. I know that I'm going to get back 2. Get 2 times 3.5 plus 6 divided by 4. So 2 times 3.5 gives me 7.0 plus 6 divided by 4. Now, many people, because they're going to see a decimal here, will think when I do this division of 6 divided by 4, I can get a decimal back here. But if this was all by itself, your answer would be an int. So that rule still applies. What's 6 divided by 4? It's just 1. Even though we know it would really be 1.5, whole number, drop the decimal, I only get the whole number back. So 7.0 plus 1 gives me 8.0 is my final answer. So those are some things you need to make sure that you are careful of. When I have 2 ints, I get back just an int when I divide. Even if there's a decimal somewhere else in the problem, and even if the data type over here is a double, that does not automatically mean that you evaluate all of these as doubles. This by itself is going to give me 1. And same thing, if I had a problem and it was double b equals 17 divided by 5, and I have 2 whole numbers here, it's going to do that division, and it's going to give me 3. So b is going to get the value of 3, but because it's a double, I just add a 0.0. I will not get a more exact number because what happens on the right-hand side of the equal sign happens first. It does not take into account whatever's on the left-hand side of that equal sign. And then just to review one last time, if you have a question and you like what order is something happening in, that's all you need to know, is what order am I going to evaluate this problem is. No parentheses, so that's easy. Then I'm just looking for anything mod, multiplication, division, left to right, addition and subtraction I'll skip. Now I'm looking if I find another division. Then I go back starting left to right and say, okay, do I have any addition and subtraction? So this will be the 5th thing that I evaluate, and that subtraction will be the 6th thing that I evaluate. So you would start out with 4 mod 10. That would give me 4. Remember, when it's smaller, I automatically just get that whole thing back. And then it would be times 6 divided by 8 plus 13 minus 120 divided by 6. So now I get 4 times 6, 24 divided by 8 plus 13 minus 120 divided by 6. Here I get 3 plus 13 minus 120 divided by 6. So I get, and be careful, you'll try to do something like this, like I just started to do this addition. I have to do this division first, so I get 20. So now I have 3 plus 13 minus 20. Again, do your addition first. 16 minus 20 gives me negative 4. And then looking at this, my answer over here, and also looking at every single number that's in my problem, is an int. So my resulting data type over here is going to be an int. So some common mistakes that I've seen made over and over again that you want to make sure that you are aware of and careful about is in using the incorrect order. Remember that multiplication, modulus, and division are all the same precedence. They're all equal. One is not better than the other. One does not always come before another one. You're just going to evaluate them left to right. Same thing with addition and subtraction. One is not better than the other or more important. You evaluate them from left to right. The next biggest common mistake is when evaluating modulus. If that first number is smaller, that's the answer. You don't have to do any math. Many times I get back the difference. So you remember when that first number is smaller, it's like saying if I had $4 and then I'm modding it by 7, you have $4 and you mod by 7. Can I get any groupings of 7 out of 4? Can I buy something that costs $7 if I only have $4? No, you can't. Well, what do you have left over? What's the remainder? The remainder there is going to be what you started out with, which is 4. And then remember that anytime I do an int and an int, my result is going to be an int. So when I divide an int by another int, my result is an int, and I drop anything after the decimal point. So if I did 4 divided by 7, it goes in 0 times. And you might think, oh, it's going to be 0 point something. Well, I don't care what that something is. Just get the whole number back, because this is a whole number and this is a whole number. So good luck. Make sure you take your time as you're going through these problems and look at them very carefully.